G'day everyone and welcome back to my channel. I'm feeling a little bit better today, but I'm still feeling sick in the stomach. My cold's just about completely cleared up, so my nose and throat's all nice and clear again. I'm not all locked up and coughy, sputtery, but I feel really sick in the stomach. I'll just show you quickly. I got all these mixed transistors from China. Not fake ones. They're just mixed from new old stock and just mixed transistors. And it's all dusty and sort of dirty. And as I was sorting through that and all these other packages which came from AliExpress, including the rest of the mono caps I was talking about the other day and some inductors, and I finally got the emitter resistors now for my amp build that's coming up. Like I said, I got the capacitors there, got the emitter resistors finally. I've got the tip 41 and tip 42Cs. Anyway, as I've been sorting through this stuff, every time I sort through it, I end up feeling sick in the stomach. So I don't know what on earth that powder is, but it looks to me like it's just a plastic dust. When you put hundreds of these devices together in a bag and they rub against each other, the plastic sort of it makes dust, but it's got like a, you know what a sadie bag looks like. It's clear. That's, I don't know what to make of it, but I swear it got me sick. Okay, so I want to go over a few things. I'll just hold the phone for this moment. I'll try and keep it still. The resistor actually goes there because it needs to, I want it on the positive side, and I want it to limit the current to this opto more than this one. And now I'll show you why I can get away with this. Use this one. As you can see, the power supply's got all zeros on its screen. Yeah, you can see that. Oops. That is not because I've disconnected something, that is because I've got the optos turned on. That's the voltage across the optos, and I think everyone noticed their threshold voltage is around 1.2 to 1.4 volts. So if they're only running at about 1.08 volts, and that brings the current down to completely zero, that's just the output capacitors discharging. I didn't realise that in yesterday's video. And my load bank injecting a millivolt. Yeah, I didn't realise that in yesterday's video, but anyway, it's not going to be a problem. They can handle up to 50 milliamps. I don't like running more than 20 milliamps into one of them, but at the moment they're not taking more than maybe a milliamp or two, so there's not going to be a problem with putting a resistor here in between this opto and this opto on the positive side, so that this one will see more current than this one. So when you're turning them off, this one will start to open up and restore the reference voltage before this one goes open. Now, let me demonstrate Don't worry about the relays chattering. Like I said, when I designed that board, I've designed it in a way that it can switch fast, but if erratic chattering situation starts, say a pot comes loose, capacitor across a pot to stop wiper coming off, causing this problem, something in the circuitry goes open and it starts fluctuating, the relays won't chatter. I'll go over how I designed the relay board. I'll have to draw a schematic because it's quite complicated. There's a lot of different protection mechanisms implemented into it so that it's foolproof. And it took 2 iterations of that, because one time I did get 2 relays stuck on it at the same time and I popped fuses, so I had to redesign it, but it's amazing now. Anyway, so very small amount of power needed for both the optos and the distant parallel without the resistor at the moment. Now I've got this analog meter hooked up across the output. The reason for this is what I wanted to show you, is if I turn the output on by taking out of current limit, as soon as you see that there's 2 volts of overshoot. Now I don't know if that's just the swing of the analog meter. Honestly, you know what? I'm gonna have to look at it on the scope. I think I'll reset up and we'll have a look on the scope. But that's what that resistor is there to fix. I just wanted to show that so that it makes more sense. I think that's what I'll do now. I'll go set up and put the scope on there, and we'll have a look if there's overshoot on the scope. Alright, I'll be back in a moment. Okay, I don't think anyone's going to quite believe this. I was not expecting it to be this smooth without... I thought there was 2 volts of overshoot. It was just a needle. The mass between the needles stringing up is making it go over and then come back. I'm on single shot mode. Alright, and I'm going to take it completely out of current limit. Sorry, in current limit. This is out of current limit. That's backing in. I know what I'm doing. I need to single. What am I missing here? Well, there you go. You can, mate, with a resistor in there, that's going to be bloody perfect. I'm happy. So, to anyone that was, and I'm not saying anyone did, I'm just saying, to anyone that was looking at the video I've just uploaded with the optos going, that's not going to work, because I won't lie, that was going through my mind too. It works. And I've got a 2 amp load on there. Should have had a 5 amp load on there to do that. There's the fan kicking on. You can hear that, can't you? And yes, the load's on. Actually, you know what? Let's do that unloaded, because it might have overshoot, but the load's pulling it down. God, I'm definitely feeling better today. It was like a struggle to move and talk yesterday. I was that drained. Alright. Let's, oh, that's where we are. Okay. Let's see what it looks like without a load. What have I done? I've turned my bloody voltage all the way down. Oh, dodgy connection here again. I think so. Oh, my voltage was just turned all the way down. That'll just be the output capacitor discharging now. Because obviously as the voltage drops, the resistor... I am going to design a shunt regulator for this too. That's something I haven't mentioned. Yeah, this thing is going to have all the bells and whistles. Right, so can we see the scope? Sorry. I guess you want to see the supply too. Yeah. That's unloaded. It's even smoother. Yeah, that seems to me. I don't know if I'm just not triggering on it properly because I'm not really set up right here. There we go. So we can see both halves if I just do it like that, so it just triggers randomly. I'm happy. I'm really, really happy with that. Alright. Honestly, that's all I wanted to do in this video. Because like I said yesterday, there's nothing else I can really do to this other than add that resistor in. So, I mean, I'm going to add the resistor in and try and get that, set up in single shot mode and tweak the settings so I can capture it properly. And I'll add some resistance to that second optocoupler and see if I can get that any better than what it is. But, hey, this is looking really nice. I don't have overshoot. Like, it's literally transitioning so fast. Now you guys get to see what I was saying when I keep talking about building a fast responding power supply, because I think a lot of people are probably thinking it's not going to be that quick. It'll be quick. So yeah, I moved that resistor for you guys in this diagram up to here, so it's in between the you call them anode positive side of the LED of the optocoupler. So we are feeding negative in here, but we're feeding in positive, yeah, right there. So this opto's got less current going to it. It's going to turn off before this one turns off, which will restore the reference voltage back, which will stop the compliance voltage from suddenly rising. Even if it's for, 2 microseconds. I don't want it going. I just want it to be, it's a linear supply. I want it to be linear. There you go, some my cats. Alright, well, that concludes this video. I know it's only a short update, but that is all it is. It's just a little update. Incidentally, I have good news. I've received, on top of the components that I just mentioned, I've received those DTA144 AKA transistors. So I'm now moving this off the bench, bringing the Yamaha mixer back over, and we're going to start working on that. Alright everyone, thanks for watching. Please like and subscribe if you like the content, of course. And get down in the comment section too. That's always good. And I'll see you on the next one. Bye for now.